Hi, we are going today to run an example of how to downscale NORA3 using SWAN and DNORA. So the first thing that we have to do is to uh, install DNORA. So we clone the repository and then we create the environment with the required dependencies. In this case, we need to install SWAN. So we need to follow the instructions in the website of SWAN wave model. And in addition, because we are going to run SWAN with wind forcing, we need to install FEMEX following the instructions at the point 3 in the documentation. So after that we have done this, we have the DNORA folder. Then we can go into the examples, and we are going to run the example with the name example model SWAN NORA3, which is open here. So if we go into the terminal, then we write cd examples. So we are then we need also to activate the NORA. So we write conda activate the NORA. I'm going to we can run the whole script typing Python and example model SWAN NORA3, but in this case here we are going to run it line. We'll use Python. Then first thing is to import the DNORA as we see here in the script. So we run the command. So we have imported the modules that we need, and then we need to define the grid object. So in this case, we are going to make a domain that is close to Bergen. So in this case, I use the card.guleser.no to find the latitude and longitude of the domain. So we define the minimum and the maximum longitude latitude covering rectangular domain. So in this case, I have 4 and 5.73 longitude, and latitude is 60.53 and 6.25. So it's somewhere north of Bergen, the domain that we have. So then I give a name of Seriham 300, and then I defined the spacing. So in this case, we need a 300 meter resolution. Then we need to read the bathymetry. So we're going to use the MET 2020. This is can be downloaded from the website of MET, so portal.memotnet-bathymetry.eu. So we choose the file that is in this area, so the D5 that covers the area. You see that includes the area of the west coast of is D5, but actually we can use also a star here, which actually is going to take to search inside all the files that belong to 2020. And then we need also to define which folder it is. Yeah, and then we have the we need to import this topo reader, this information into the grid. So I'm going to run this command, and then yeah, so this reads the topography bathymetry, and then we need to mesh the grid. So we type grid.mesh grid. So here we use the linear interpolation for meshing the grid. And after this is finished, we are going to set up the boundaries for the domain. So we're going to set the area, which actually we need boundaries. So in this case will be north, west, and south. So in case, like, we need to have the north boundaries at the west and the south, and not in the east, since it's land there. The step is 20, which means that every 20 points we get a boundary information. So, and then we set this information into the grid by grid.setBoundary. So let's run this command, and of course we got also some information when we mesh the grid, which actually contained like what is the mean depth, what is the maximum depth of the domain, and how many C points or land points we have. So then here, so yes, so now we set the edges to the boundary points using the step of 20, as you can here. So now we finish defining the grid object. So the next step is to define the model object. So here we're going to say which kind of model and boundaries forces we're going to use. So in this case, we say model.SWAN NORA3. So we're going to run SWAN model for downscaling, and NORA3 is going to give the boundaries and the wind forcing. We provide the grid and the start time and time of the simulation. In this case, for this example, we have just used 3 hours, but it's up to the user to use how many days wants. Of course, this needs to be also within the period of the NORA3 data. So it's from 1992 up to 2020, the days that is possible to provide here. So let's define the grid. So yeah, the grid is ready. And now we need to import the boundaries and the forcing using this command here. So we import boundary and forcing. So the first is the boundary. So we get the boundaries. We see also the distance, the closest distance of every boundary from the NORA3 we get, and then we get also the forcing. So the wind forcing. So the program is getting the data from threads.met.no, both for boundaries and wind forcing, and creates actually a temporary file that we see here that has this data. So yeah, and then this is optional. It's to plot the grid, the forcing, and the boundaries. So just in this case to see how the um, uh, where the boundaries are located and our grid and topography. So now this creates a file which is actually the project name underscore the model. So it's underscore SWAN. And then if we click on it, we get this uh, um, this PDF file where we see the boundaries with the stars, the available spectra from NORA3 with the X here, and the forcing from NORA3. We see all the points that we get with the red. And of course, the color bar represents the bathymetry, the depth. So here, okay, this looks okay. So we can continue um, on to write output files that contain the grid, the boundary forcing, and also the input parameter file for SWAN. Everything will go into this file that we have here. So then we just oops. So yeah. So then let's see one by one. So here we should output the grid. So yes, so we get we get a grid actually. So it's how it looks like the grid file for the SWAN. And we get also an info file, so some information about the grid. Then we continue to export the boundary. So we're going to generate a file that contains the NORA3 boundaries for the domain. So here we are. So we have this ASCII file that contains all the 2D spectra, directional spectra for the SWAN around. And then we continue to export the wind forcing. So here, yeah. And then here is the NORA3 actually wind forcing, how it looks like. That is going to force the SWAN model. Actually, this step here for the wind forcing, as I said before, include that you need to have installed Fimex in your PC. Otherwise, if you don't want to run SWAN with wind forcing, we can just skip the installation of Fimex, but then you need to comment the area of import forcing and of course export forcing, so you don't have forcing, and then you're going to run the model with only with propagation of the boundary spectra. So then we are close to the end. So we have the just to write now the parameter file. So then we type model.write input file, and we are going to get this file that has extension .swn, which actually it's all the information of that SWAN needs to run. So it's the input parameter file for SWAN. So all the files now are located in this folder. And then if we want to run SWAN within DNORA, then very simple, we can just type model.run model, and then we execute SWAN. So the SWAN starts to run, and already has generate a file that we see the project name that we have, underscore the date that we gave the start time, .nc. So it's an HTTF file. So yeah, and with this we have started the downscaling of the NORA3 into the domain that we have defined here, and the time, of course, that we have defined here. So yeah,